Hello everybody, this is Anushka and we already started a new chapter called Heat, and in this video we are going to continue the heat. Are you ready? Let's start. This topic specific heat is very important and I'll try to explain to you as simple as you can understand. At the end of the before video we done a last activity and we concluded that raise of temperature depend upon the nature of substance. Did you remember that? If you don't remember, let's recall that again. Here is the picture. Take two test tubes, one with water and one with oil, weighing 50 grams both. Now clamp them to retort stands. Fix two thermometers inserting through corks. Make sure the temperature of water and oil should be at 30 degrees approximately. Now place them in a jar of hot water. After observing the readings of thermometer for every 3 minutes, we conclude that the rate of rise in temperature depends upon the nature of substance. That means, according to the nature of substance, there should be a specific heat supplied to raise the temperature of that particular substance. This is what we call as specific heat. The amount of heat required to raise the temperature of 1 unit mass of any substance by 1 degree Celsius. Specific heat depends upon three terms. One is Q, M and delta T. Q means heat, M means mass and delta T means change in temperature. With these three terms, let me derive the formula for specific heat. Are you ready? We are going to do some activities. With that two activities, we will derive the formula for specific heat. Activity 1, we should prove that Q is directly proportional to mass. To prove Q is directly proportional to M, take a beaker containing 1 kg of water at 30 degrees Celsius. In another beaker, take 2 kg of water at 30 degrees Celsius. Try to supply heat to both of them for 10 minutes or more than it to change the temperature into 50 degrees Celsius. Hence, it is not possible to raise the temperature in beaker B to 50 degrees Celsius for the given time because rise of temperature depends on nature of. Here, we took 2 kg of water in beaker B. It means it takes more time to attain the temperature 50 degrees Celsius. Since that heat decreases, mass also decreases. Since mass decreases, heat also decreases. Q is directly proportional to M. Let me see this Q is directly proportional to M as equation 1. Now second activity. To prove that heat is directly proportional to change in temperature, take two beakers containing 1 kg of water named A and B. Both should be at 30 degrees Celsius of temperature. Try to supply heat same for some time. The temperature of beaker B should be 50 degrees Celsius at reaching. The temperature of beaker B should be 80 degrees at reaching. But we are giving the same time. Hence, Q of beaker A is less and temperature is less. Q of beaker B is more, temperature is more. Hence, Q is directly proportional to change in temperature. Now, from the equation 1 and equation 2 combination, we derive Q is directly proportional to M delta T. Now we can keep a constant in the place of delta. It means we have to derive the formula for specific heat, right? Let me say specific heat as S and let me keep the constant S in the place of directly proportionality. Okay, now Q is equal to MS delta T. It is important to derive the formula for specific heat, so make the S to come into the LHS and now the remaining terms into the RHS. Now S is equal to Q by M delta T. Units of specific heat is in the CGS system calorie per gram degree Celsius and in the SI system joule per kg Kelvin. Hence 1 calorie per gram degree Celsius is equal to 4.186 into 10 to the power 3 joules per kg Kelvin. In the before class we learned about kinetic energy, the energy that a body possesses when it is in the motion. Now this kinetic energy is in the form of 4 types: linear, rotational, vibrational and potential. These are the 4 types of kinetic energy. There's no need of learning this 4, but as for your idea, this 4 kinetic energies comes under internal energy. Don't get confused about saying the word internal energy. Internal energy is nothing but the energy which is inside our body. A material attains temperature when it has more kinetic energy. It has less kinetic energy, it attains less temperature. It means if temperature increases, kinetic energy increases. If temperature decreases, kinetic energy decreases. Coming to the point of specific heat, there are 3 important points to learn about specific heat. Note in your notebook, these 3 are very important points. Specific heat gives reluctance of a body to change its temperature. Specific heat of water is 1 calorie per gram degree Celsius. Water has highest specific heat when compared to other materials. Alright, let's stop learning for a minute and let's try to complete a task. The task was, I will display 2 questions on the screen and I'll give 10 seconds time to you. Pick a question and try to answer the question in 10 minutes. Okay, the 2 questions. John kept a watermelon and a pomegranate in refrigerator just now. Can you tell which one of them will become cool fast and why? The question number 2. Lizzie prepared samosa just now. She opened the samosa and observed the curry inside it. She noticed that the curry is very hot. Can you tell me why? Pick one and answer one. Your time starts now. Okay, are they tough? I think they are not so. Answer for the both questions is same, specific heat. As there should be a need of more heat supply to water, specific heat of water is more. Now, when compared to watermelon and pomegranate, watermelon has more water content, so more specific heat supply. It means this cools more faster than pomegranate. Because pomegranate has less water content, it needs less specific heat. It means it does not cool more faster. It takes more time to cool down. These are all applications for specific heat. And let me say one more example and one last example. We say oceans store heat. Ocean water transport heat from equator to pole. Hence, ocean water controls atmospheric temperature. This is why we say oceans are heat store reservoirs. There were many explanations like this, very bigger explanations. There's no need of learning this all big explanations. Strictly one point. Oceans transport heat from equator to pole. That heat comes from the poles. Alright, now here is the principle. Now you know the formula for specific heat. S is equal to Q by M delta T. Alright, you know the formula. Q is equal to M delta T. Now let me separate both LHS and RHS. LHS Q1 is equal to Q2 and RHS M1S1 delta T1 is equal to M2S2 delta T2. Keep in mind, principle of method of mixtures is very important because we are going to use this principle while you are practicing the problems. Okay, while you are solving the problems, this is very important. Now it's thinking time. Some words are displayed on the screen. You just try to think the definitions for the 6 words. Make sure you have to think the exact definitions of 6 words. Alright? Pause the video and take your own time. If you remember the exact definitions for all 6 words, comment below that you remembered. Fine. Now let's see the definitions for 6 words. Now let's see the simple definitions for 6 words. The phase where liquid converts into gas at a constant temperature is called boiling. The phase where liquid converts into solid is called freezing. The phase where gas converts to water is called condensation. The phase where solid converts to liquid is called melting. The amount of water vapor present in atmosphere is called humidity. Now let's try to describe each words in simply 2 or 3 points. Let's get started with evaporation. Evaporation is a cooling process and escaping of water molecules happened at any temperature. Okay, so it may be happened at your room temperature also. You will see the process of evaporation. Daily you are observing the process evaporation. Evaporation is a cooling process and it occurs at any temperature. There is no constant and particular temperature for evaporation. It takes in any temperature. Evaporation is a surface phenomena and during this phenomena, the temperature of the system falls down. Hence the body get cooled and the system get cooled, whereas heat is escaped, whereas heat goes out from the body. Evaporation depends on 4 factors: temperature, surface area, wind speed and humidity. In this 4, temperature, surface area and wind speed, these 3 factors will increase the rate of evaporation, but humidity is the only factor that decreases the rate of evaporation. To understand about evaporation, here is a picture. A small activity. In this activity, we see the apparatus, Bunsen burner, stand and Bunsen burner, table, retort stand, tripod stand and thermometer, beaker, ice cubes. Also we observe water. And observe the graph now. We started heating up with the Bunsen burner and we kept ice cubes inside the beaker, and we also set up a thermometer inside it. Now when we start burning the ice cubes are at minus 5 degrees Celsius, and we start burning up, they attain the temperature of 0 degrees Celsius. Hence the ice get converted into water at the melting point. We already know melting point. Let me discuss it in the upcoming time. Now, when the ice get converted into water, and then water get raised up to the 100 degrees Celsius after some time, and it is the boiling point. Then the water get boiled, water converted into gas. After conversion of gas, what gas get raised as steam, and this is the graph of the activity. And this is the graph of output that came after the activity. Melting takes place at a constant temperature, and that temperature is called as melting point. Melting point of ice is 0 degrees Celsius, and melting takes place at this particular temperature only. Actually, when a solid converts into liquid at a constant temperature or at its melting point, it has to observe some heat energy, and that heat energy is called as latent heat of fusion. Latent heat of fusion is denoted as LF, and the formula for LF is equal to Q by M, heat by mass. Units of this latent heat of fusion are, CGS units are calorie per gram degree Celsius, and SI unit is joule per kg. Latent heat of fusion of ice is 80 calorie per gram. This is very important value. We are going to use it in the problems. Coming to the point of boiling. Boiling occurs at a constant temperature, and that constant temperature is called as boiling point. Boiling point of water is 100 degrees Celsius or 373 K. Boiling point of water is 100 degrees Celsius or 373 Kelvin. Actually, when the liquid converting into gas at a constant temperature like boiling point, it have to absorb some energy. That heat energy is called as latent heat of vaporization. This is also very important formula. And SI units and CGS units are also displayed. CGS units is equal to calorie per gram, and SI units is equal to joule per kg. Take screenshot for this. This is very important. Just take a snap. Okay, cool down for a minute because you all have tired up by listening my lecture. Okay, if you're not tired up, so and let's activate our brains. During boiling, we observe some bubbles at bottom raised to top. Why? Option A, due to more specific heat. Option B, latent heat of vaporization. Option C, due to change in temperature. Option D, due to dissolved gases presence. And the right answer is D, due to dissolved gases presence. Alright, now let's talk about condensation. We already know the definition of condensation. Condensation is also called as a warming process because it's always increasing the temperature of a system. And the point where condensation takes place is called as condensing point. Condensing point of water vapor is 100 degrees Celsius or 373 Kelvin. Now, another task for you. Water droplets will form on surface of bottle which is with cool water. Why? Option A, evaporation. Option B, freezing. Option C, melting. Option D, condensation. And the right answer is option D, condensation. Generally, liquids contract on freezing, but water get expanded on freezing. This different behavior of water is called as anomalous expansion of water. Now the one last word, humidity. The amount of water vapor present in atmosphere is called humidity. Let's see some situations related to humidity now. If we stay in bathroom after completion of our bath, we feel hot due to condensation of water vapor on our skin. And another example, of course, this is hot and heat summer days, and we feel sultry due to this humidity, of course. Alright, almost we came into end. In winter days, condensation takes place on the dust particles and form a thick mist. This thick mist is called as fog. This thick mist restricts the visibility. Second one is dew. Water droplets which are formed on green leaves or windows and other glass things is called as dew. We can observe the water droplets formed on those things. This is what we call dew. Perfect. This is all about today, and in the next video let me meet again. Up to that, don't forget me. Keep learning. Bye bye.